Welcome to Agentic Orchestration for RPA developers, where we will explore the LangGraph foundation to help elevate your automation strategies from basic rule-based execution to cognitive reasoning. In this section, we will examine the paradigm shift occurring across the enterprise automation landscape, specifically the transition from traditional robotic process automation to agentic orchestration. Throughout our discussion, we will establish critical learning objectives. You will learn to clearly differentiate linear RPA limitations from the capabilities of stateful agentic workflows. We will map the RPA terminology you know directly to the LangGraph architecture. You will evaluate strategic application frameworks to guide precise tool selection. Finally, we will transition your mindset from building deterministic routing to designing cognitive conditional branching. We begin by moving beyond linear flows, dissecting why the rigid pathways of traditional automation are no longer sufficient for managing the complexities of modern enterprise operations. Transitioning to agentic orchestration requires a shift in how we approach automation, moving away from linear tasks to embrace stateful, cyclical execution. Traditional RPA operates on highly rigid, rule-based sequential paths. It excels at performing repetitive actions where inputs are predictable and outcomes are binary. However, this deterministic approach severely limits adaptability when unexpected exceptions occur. Agentic orchestration leverages dynamic, self-evaluating reasoning loops instead. Rather than blindly following a predefined flowchart, an agentic system evaluates its environment, determines the next best action, and can iterate on its own logic until a satisfactory outcome is achieved. This represents a leap from just doing the work to actively reasoning about the work. To understand why traditional automation struggles with complexity, we must look at its underlying structure. Directed Acyclic Graphs, or DAGs, are the mathematical foundation of standard RPA flowcharts, and they inherently prevent the iterative loops necessary for cognitive revision. By definition, DAGs prohibit upstream backwards movement during execution. Once a process moves forward, it cannot autonomously loop back to reevaluate based on new insights. Because of this strictly forward momentum, DAGs require developers to build explicit, predefined routes for every possible exception. This architecture fundamentally fails when handling unstructured data, requiring multiple analysis passes, because the system cannot circle back to cross-reference new findings with earlier extractions. Modern enterprise applications encounter a level of ambiguity that strict rules simply cannot resolve. Enterprise workflows increasingly involve unstructured text, highly varied document formats, and ambiguous user intent that mandate active cognitive evaluation rather than simple deterministic mapping. For example, processing complex legal contracts requires an orchestrator to continuously interpret outputs, correct its own errors, and intuitively determine the next logical action without needing explicit human programming for every edge case. In a scenario like insurance claims processing, the system might encounter a handwritten note that contradicts a standardized form. A linear bot would crash, but an agentic model uses complex reasoning to evaluate the discrepancy and proceed intelligently. Unstructured data is the ultimate stress test for any automation system, and it requires an orchestration model capable of iterative refinement. When we extract unstructured inputs from diverse enterprise sources, the data rarely arrives in a clean, predictable format. To handle this, we must evaluate the data context dynamically, using cognitive agents that parse meaning, rather than just searching for keywords. Furthermore, when these agents encounter incomplete information, they must be able to refine their understanding through cyclical queries. If a crucial piece of data is missing from an initial document extraction, the agent can loop back, prompt a user for clarification, or query a database, seamlessly integrating the new information into its analysis without breaking the workflow. This brings us to the technological solution driving this shift. LangGraph provides the framework necessary for cyclical, multi-actor orchestration. Fundamentally, LangGraph functions as a robust Python library specifically designed for building stateful, multi-agent applications. It treats workflows as graphs, where nodes execute discrete actions and edges route the data and control flow between them. What truly separates LangGraph from standard orchestration tools is that it natively supports cycles, allowing agents to iterate continuously until conditions are met. This means you can build applications where an agent drafts a response, another agent critiques it, and the first agent revises it, passing the work back and forth in a loop until the final output reaches the required standard. The cornerstone of this advanced capability is stateful multi-actor orchestration, which ensures memory continuity across disparate cognitive tasks. Maintaining a shared context across independent agent nodes is vital, because it allows different parts of the system to access the same centralized memory payload. This enables multiple specialized actors to collaborate on a single task. For instance, you might have one agent dedicated to web research, another focused on data synthesis, and a third responsible for final formatting. Because the system is stateful, they all share a continuous understanding of the overarching goal. Furthermore, this architecture persists execution history to support capabilities like pausing a workflow, reviewing reasoning, and rewinding execution to correct errors.